Well, today it's all about fans. I'm going to show you the different types of fans there are that can be used in a PC case, how you get the most out of the fans, how they should properly be installed, which direction is the air going to be blowing in or out. Also, the proper placement in the different locations in the case. The whole idea here is, one of my biggest pet peeves, is to keep things cool inside your PC case, because heat is what will eventually destroy your components. And some of them, as we all know these days, can be quite expensive. So I'll be talking about these fans, I'll be talking about different types of fans, the proper use for certain types of fans. I'll be talking about filters that you can use to keep the dust out of your PC, and how, if you properly place your fans in the case and you have them configured in the right way, you can actually keep the dust down to a minimum. And that in itself will keep the heat out, because dust tends to accumulate and causes components to overheat if the dust accumulates on them. But if there's no dust, then that particular thing is not a problem. So let me go ahead and show you what I have here. Now I'm going to show you the different types of fans that I deal with. I'll start with the ones I like to use best, or the type of fans that I like to use best. Both sets of these, and I have 4 of these and 2 of these, they're all referred to as PWM fans. PWM stands for pulse width modulation. You can identify this type of fan by the 4 wires that it has in its cable. 2 of them are the power, plus and minus 12 volts. The third one is a speed sensing wire, and the 4th one is a PWM wire. This thing always has the same 12 volts applied to the logic in the center of the hub that controls its speed. However, it senses what the speed is and sends it back to the controller, which could be the motherboard or a fan controller that's separate from the motherboard. Either way, I usually use the motherboard most of the time. And then that controller would adjust the width of the pulse coming in on the PWM connector in order to control the speed of this fan. Now, I could make a whole video just about the electronics behind that. If anybody's interested, just put comments below and I'll be glad to do that. Now, this one has RGB. This one is not. But even though this one's RGB, it is less expensive than this one. This one also is only 13 millimeters thick. And that's good if you have very tight quarters that you want to put a fan in. Just like my original server that I have downstairs, my NAS server. This one is a standard 1-inch thick, which you would usually see in most cases today. However, the range of the speed between these is what determines how valuable they are and how much they will charge you for it. These are better because they have a range of speed that will actually go from 400 to 2400 RPMs, whereas these, they can only go from about 200, I believe, up to 1400 RPM. And that range of speed is critical to the performance of the fan setup that you've created. The wider the range like these, the more control, whatever controller you have, whether that's the motherboard or a separate fan controller, will be able to exert on keeping that particular device, in this case a PC, properly cooled. So these are the Primo fans because they are PWM. Now, I happen to have them here in the 120 millimeter diameter, the most popular one that you'll see out there, but they don't only come in that. Over here, I have a PWM fan that's only 80 millimeters. And in this one, they didn't paint all the wires black and they didn't bond them together. So the 2 black connectors are the voltage, plus and minus 12 volts. The yellow, I believe, the yellow is the sensor, the speed sensor, and the green is the PWM. I'm not 100% sure about that, but I'm pretty sure. You could always look up the regular PC fan connector and see what the pinout is, okay, to find out for sure. But it doesn't really matter, because whatever controller you have, it will know what the pins are. Now, these are all PWM, but in addition to PWM, the next step down from that are what we refer to as DC fans. A DC fan is identifiable by having only 3 wires. And the 3 wires happen to be plus and minus 12 volts, and the third one being the speed sensor. And then what the controller does with a DC fan, and this is also Corsair, but it's much cheaper than the PWM sister to it. The controller, or motherboard in most cases, which is what I usually use, it will adjust the voltage. It'll lower the 12 volts to some lower value to cause this thing to spin slower. It is not as responsive, and it usually doesn't have the same range of speed to it when it does it that way. I don't have the exact specs on this. I would bet that this one is more in the order of, like, it goes from 800 RPM maybe up to about 1600 RPM. And that's the only range that it has, which is not very good. And again, not being responsive, which means it'll be slow to react, is also a problem. This also comes in 80 millimeter. This is 120. They also have it in 80. This was also came with a case that I bought. One that I think I recently had on one of my videos, my wife's old computer. It's a DC fan, 3 wires. If you want to go back in history though, and they still sell these and you want to be careful of it, you could even go to a lower degree of fan. This one is only 12 volts with no PWM, no DC, only 2 wires to it, plus or minus 12 volts. It even has one of the old Molex connectors that you connect directly to the power supply, because this is not going to be controlled by anything at all. It's going to run at the maximum speed that it supports, which I don't even have an indicator here what that is, at all times. So you have no control at all in terms of adjusting this. Chances are that that maximum speed is going to be less than a PWM fan. Just the way they do it, just to keep the noise down. So this is really cheap. I think this one cost me like $4. A standard DC fan you generally get for about $8 or $9, and the PWM fans tend to be much more costly than that. But let me also talk about something else related to this, and I'll show you more about this later in the video as well, and that's filters. Here is a magnetic filter that I bought separately, and I have this on one of my computers. This is also the same type of filter that comes usually in the top of certain cases that are mid-range. If you look very carefully though, the mesh is not very fine. And the whole idea here is you want to have a filter. Basically, any fan that's blowing into the case, you want it to be able to filter the actual air that's going in to some degree. So let's say that the fan is blowing in this direction into the case, which it happens to be that direction, and I'll show you that in a moment. Then you'll put the filter here on this side, and this is 240, so you can actually put 2 fans side by side in order to support that, right? So this is wide enough for 2 fans. They also sell this in only 120 millimeter width. I've never seen it in 80, but I've seen it in 120. I think I have some downstairs actually. This is magnetic, so if you have a case that has the much larger holes, or you decide to cut into the case, then you can just stick this onto the side of a metal case. If you don't have a metal case, well, first of all, that's a problem because you should have a metal case itself. But let's say you want to put this on the front of the case and it's not metal, like I'll show you in one of my mods coming up for my new primary editing rig, then you have to account for this magnetic, have something that it can stick to. And I'll show you that when I do that mod. But if you look at this, it's not very fine. I mean, the holes that are in there are pretty large. There's another version of this that's more costly that is very, very fine. This will filter out much more of the air, taking all of the dust out of the air. It will get dirtier faster, but it'll keep the case cleaner. So you have this one, which has, small holes, but these are ultra small holes. This one also costs more. And the high-end cases, this is the type of filter they normally put on the front of the case. So that's a quick introduction, but I'm going to cover a lot more than that in this video. In addition to showing you how these go into the case, which I'll do next, I'll also be showing you some of the ways you could test this all to make sure it works properly. And I'll even talk about how to set it up in the BIOS to automatically adjust the fan speeds to meet your system need. So let's move on to that. Okay, I've gotten into this particular PC's BIOS by hitting the delete key as it started to power on. This particular motherboard is an MSI MPG Z390 that's gone into my new, well, soon to be new, editing and secondary streaming rig. And you do have some control over the fans on this particular one. So you need to pick the right menu. Every motherboard manufacturer is different in terms of the options they provide to you, and this is no exception to that. So we want to go into the monitoring, hardware monitor, and fan control button, which is right here. Now what you see across the top here are the different fans that you have in the system. Now in this particular case, I have a dual CPU fan, which because it's got a 240 millimeter AIO up at top, it's also got a pump that's associated with that AIO, and it's got 3 other system fans, which are plugged into system fan 2, System Fan 4, and System Fan 5. As I said when I was building this PC in a previous video, you need to plug into the nearest fan header so that the motherboard can properly sense whether or not that fan needs to be spun up to a faster RPM or not. What you're going to have to do is make sure that you have these things properly configured one by one in this particular motherboard. So right now it's set on the CPU fan, highlighted here. That one is set for PWM, but we could set it for DC if we wanted to, and that would make it less effective in terms of a fan, because now it'll adjust the voltage rather than actually adjust the PWM speed of it. Just so happens that this particular one, it was already set before I even started to a PWM mode. And you also need to check, in this case, for this motherboard, what the temperature source is from. This one is going to use the CPU temperature as its primary source, although we could change that if we wanted to. Wouldn't make sense in the case of a CPU fan. The pump itself is always a DC type fan. It uses the same power and the same controls as a fan, but it's always running pretty much at maximum speed, so it really can't be changed. So that's why you see it running at such a high speed right now. It's always doing that. But let's pick the first one that is a real fan, System Fan 2. And that is the back fan for this particular PC, just where I plugged it in. If I click on that, it is currently set for PWM. It is taking its temperature source from the system as opposed to the CPU. It just so happens that there is sensors on the motherboard near that fan that will use to spin up or spin down the speed of the fan. Now we can adjust how the fan is sped up or how it's slowed down in terms of seconds with these particular options. It's set for the shortest time frame of 1/10 of a second, but you can increase that if you see a need to, if you think it's spinning up too rapidly or not. I have to click on one to get out of it. Now also there is this option here. You can turn this off and it will only run one particular speed. It won't know to adjust it based upon the temperature, and that is not the ideal case as for a PWM fan. So we do want to turn that on so that we will pump it up and it will adjust different speeds, and the speed is over here in the right hand column, depending on the temperature. And here's two columns on this particular one, temperature in degrees centigrade and temperature in degrees Fahrenheit. So whenever it hits, let's say 50, it's going to speed up to 3,500 RPM. If it ever hits 90 degrees centigrade or 194 degrees Fahrenheit, it'll be up to 6,300 if the fan supports that. So it all depends a little bit on whether the fan will support that or not. This can be changed. So you can take this and you can drag it to a lower volume. There's a little box associated. It has to stay within the constraints of the other two temperatures. But you can tweak it any way you want. If you pick this bottom one, you can actually tweak it quite a bit, all the way down if you want. And you can cause it to come right back up rather rapidly. And you go through each of your fans that are connected. And you should make sure that, because sometimes these here are set as DC, and you don't realize that because it doesn't show the speed. You want to pick your fans. For example, if I pick System Fan 4, let's say I turn it on to DC. Well, over here on the right, it shows you that it's going to change the voltage to adjust. So it doesn't see the PWM signal, so it will go ahead and change the voltage here to adjust how fast the speed will go. And it shows you the different voltages that it uses for different points. Right now it's at 7.2 volts, but it can go up or down from that. If I change it to PWM, now what do you see there? You see the actual RPMs that the fan is running at. And over here, this little diagram is nifty. It shows you what the fan speed has been for, the last couple of minutes. It's constantly scrolling across. But you just need to go into here and actually check to make sure that all of your fans are properly set. Some motherboards even have advanced features where it can adjust the fans automatically. I know that a lot of the Asus motherboards support that, and there's a button here to have it go through and calibrate the fans based upon where they are and where the sensors on the motherboard are. It'll get very close to the ideal speed that's needed to adjust for different temperatures. It's a very interesting program. I'm not going to cover that in this video, but I could cover that if people are interested in a future video. So that's a quick demo of the fan controls you can do with the motherboard. Well, at first glance, this may look like a nice computer that I've recently put together. Well, in reality, let me show you another angle here. There's actually no computer inside of this case. It's just a case with some fans and no computer at all. Let me pull off the cover and you'll see what I mean. So really all that's in it is an empty case, the fans themselves, some wiring, and a fan hub. And the fans, if I get closer to it, you will find out, are actually running at very high speed. Their maximum speed that can be run. I put this together just to do a demonstration of the fans. I actually have in it a total of 6 fans. 4 of them are RGB, as I showed you in the first part of this video. And the other 2 are non-RGB, but they are faster. They are all PWM fans, and they will run at a higher RPM. It's one up here and one down here that are standard Corsair fans that are running right at this point at a maximum speed of probably about 2,400 RPMs, whereas these here, they're running at only about 1,300 RPMs. Now let me show you why I put this thing together. Okay, so what I have here is 6 fans installed, the same 6 that I showed in the beginning of this video. There's 4 of them that are RGB and 2 of them that are not. Over on the front of the case, I have 2 of the RGB ones, and these are the thin ones, only 13 millimeters thick. And I have one that is non-RGB, that is 25 millimeters thick, or a full inch, and that one's not RGB. And then in the back, I have another RGB one, another thin one. And then over here on the top, this is the top over here, I have one non-RGB and one RGB. Now they are oriented in such a way that the ones on the front, these here, because you can see the actual bracket that holds the hub in place on all three of these. And if you looked at the curvature of the fan blade, you would see that we see the concave part of it here. These are all blowing in, all three of these. The one in the back is the opposite. It's reversed, so you don't see the cage that's holding the hub, so it's blowing out, and also the non-concave part of the fan blades. And on the top, the same thing. Both of these are set up so that they're blowing out of the case or to the top of the case. Now, why did I do this? Well, I did this to make my point about proper installation of fans. This one here is fairly neutral in terms of the airflow that's taking place inside of this case because of the way I've done it. These here are faster, this one and this one over here. The other four are slower. That's why I have two of the slower ones and one fast one blowing in, and I have one fast one and two slower ones blowing out. So it's going to be fairly close to neutral, although the way it works is there is some resistance when you're trying to get out of the case a little bit, so you will have a little bit of a positive airflow, but we'll test that. Now, what is the advantage of a positive airflow? You see all these little holes in here all over the place, you know, these PCIe brackets that are not used, this part here above the back fan, and all over the place. There's a lot of openings. Those are openings that you have in the case, and most cases have that. By having a positive airflow, the air will go out of those holes, the excess air inside the case, because the pressure is higher than atmospheric pressure. If I were reversed to that, if I had less fans blowing in and more fans blowing out, and when you add up the cumulative speed of the fans, you know, you can figure out what the difference is. If it had a negative airflow, then these holes here would actually suck air in to make up the difference. All of these holes that you see here, they would suck air into the case, and guess what? None of that is filtered. Whereas the very front of this case has two levels of filter on it. There's this really coarse filter on top, but let me show you what happens when I open up and pull the top off. Guess what's right behind the coarse filter? On this particular case, not all of them have it, but the higher quality ones will have it. This is a magnetic, fairly fine, not super fine, but finer than the coarse one we just saw in terms of filtering out dust and other particles in the air. So the air going in and being sucked in by these three fans, because they are all sucking in, will be fairly clean because they're going through first the coarse part of the case, this coarse filter, these large holes, and then this fairly fine filtering over here. And that's what the objective is, that we try to filter all fans blowing in to the case. The ones blowing out doesn't really matter. Hopefully there's very little dust in here because you do have a positive airflow. Now let me go ahead next and show you how we can test this. So the easiest way to test this, believe it or not, is with a piece of tissue paper. In this case, just a plain tissue. Clean, of course. And if you hold it over the fans, you will see which way the fanned air is blowing. It sort of makes sense because that's the way I have them oriented. So these two top fans are blowing up, and therefore the tissue floats above it. Whereas the front fans, what do? They're sucking the tissue in because they're blowing in. Okay? And the back fan just as well. It's blowing out. But if you wanted to really see if you had a positive airflow or not, well then, let's say this little opening right here underneath the fan, where we had the actual large holes coming out, if we hold the tissue down there, what do we get? It is blowing out. It is not sucking in, which means that we have a positive airflow there. So this case now has a positive airflow. Just by pure chance, in terms of the fan speeds that I have more air being pumped into it than being pumped out. Therefore, you have a positive airflow. Now, there is another way to demonstrate this, so let me show you that. Have you ever seen incense? These little sticks that you burn, they give off an aroma. There's a lot of different choices in what the aroma is. So if you have some of these, well, there's an alternative way to see how the airflow comes in and out of this. So let's try that. One thing about the incense, it puts off a lot of smoke, harmless smoke, that you can then try to trace. So if I go ahead and put it in the front of the case, where is the smoke going? It is going into the fans. And if you look very carefully, it's hard to tell with this lighting, it is actually coming out of the back fan and the top fan as well. Okay, that's where the smoke is heading. I could also put it up on top, and guess where the smoke is blowing at this point? It is blowing only up. Don't get too close to the fans when they're high speed like this, but it is blowing up. And the same thing for the back fan. And what it's really handy for are these little openings here. So if you go to one of the openings, you will actually see where the smoke is going from those openings. And you can check all of the openings in the case to see which way the smoke is going. Is it being sucked into the case or is it blowing out? A pretty good test of what it is. So right now it is blowing out of the case. Okay? So that's an alternative way if you happen to have these incense and you have a smell that you don't mind. This particular one is fairly good, but I'm still going to air this room out a little bit once I'm done. Well, that completes this video on fans, PC fans in particular, and the proper way to install them on your PC case, the proper way to enable positive air pressure, which is a concept that I covered in considerable detail, and how important it is to keep the dust out of your PC, and a combination of the good airflow by making sure that the fans that are in the front and bottom, if you have any, are blowing in, and the fans that are blowing out the back and up are blowing out. That's the basic rule to remember. Anything in the front and the bottom, blow into the case. Anything on the top or on the back, blow out. And make sure you have an equal balance of the different fans in terms of making sure that you keep that positive air flow within the case itself. That'll keep the dust out, and the dust itself, by keeping that out, will also ensure that your PC will not overheat and last a lot longer. So hopefully you got something out of this video, and if you did, at least consider subscribing to my channel. That way you'll be able to see videos like this in the future. And I plan on getting into some really technical issues in the future that might be very helpful to everybody. So with that, I'd like you to take care, stay healthy, and stay safe.